The rig welder plays an important role in Sedco Forex. As well as maintenance and repairs, the welder has an essential role in the weld construction process. In an emergency, he can become one of the most important people on the rig. Welding and cutting are familiar activities in our business. They are extremely versatile and have many applications around the rig. It's important to remember, though, that these are potentially hazardous operations, to be carried out only by properly trained individuals. In this video, we'll look at the role and responsibilities of the welder in Sedco Forex, and how his job can be carried out safely and effectively. Before any job can start, you have to make sure it's safe to work. Begin by checking that there are no special circumstances which prevent the work going ahead. During fuel loading and drilling operations requiring radio silence, no hot work is allowed. Hot work includes welding, cutting, burning, and other activities which may generate sources of ignition. One of the major hazards when undertaking hot work is the presence of gas, so check the gas state of the well with the drill floor and mud loggers. Then perform a gas check of the area where the hot work is to take place. Unless you are working in the designated welding workshop, you will need to fill out a hot work permit. This permit helps you and your supervisor decide whether it is safe to begin a welding job. A correctly completed permit will show that you have carried out the appropriate pre-job checks and considered any special requirements. If, for example, you're going to be working in a confined space or at height, you must show the additional equipment and procedures on the permit. The completed permit should be given to the appropriate person on the rig for authorization. Check with your supervisor if you're not sure who this is. The person authorizing the permit will check that all the necessary precautions have been taken and that the job does not interfere with other work permits on the rig. One copy of the completed permit should be displayed at the pre-designated area so that other people can see what work is going on. Another should be displayed in the work area to show that your job has been authorized. Remember, a hot work permit is only a piece of paper and cannot protect anyone on its own. You must ensure that you follow the safe work procedures detailed in the permit and not deviate from them. You should also be aware that permits are only valid for a set period, 1 day or half a day, and only for the specific job they describe. If you start a new shift or a new job without a new permit, then the work you are doing is unauthorized and may endanger the rig and its personnel. Because welding generates arcs, sparks and slag, the welder must be protected from head to toe. If you leave any gaps, the chances are a spark will find its way in, and that's going to hurt. Let's begin with the coveralls. These must be flame retardant, and any clothing worn underneath should be either wool or cotton with a flame resistant treatment. Artificial fibers, like nylon, should be avoided, as sparks can cause them to melt onto the skin. Welders should wear coveralls without pockets to prevent the danger of trapped sparks. But if yours do have pockets, make sure they are closed and fastened. One other thing, you should never carry anything flammable in your pockets. If sparks come into contact with matches or a lighter, the result will be extremely painful. To protect your feet from sparks and slag, you must wear leather steel toe-cap boots, and make sure the legs of your coveralls are on the outside, if you want to avoid a case of hot foot. While you're setting up, clean cotton gloves should be worn. But for all hot work, you must wear leather gloves which are long enough to protect your arms. A welding cap will prevent any stray sparks from getting into your hair and make you more visible to other people. But unless you are actually welding and wearing a visor, you should always wear a hard hat. Eye protection is very important during welding jobs. Tinted lenses will protect your eyes, and a full-face visor will protect your face from sparks. When preparing the workpiece, whether by grinding, chipping or brushing, you should wear goggles instead of ordinary safety glasses. Once at the work area, you may need to take other precautions specified in the permit. For example, machinery near the work area may need to be locked off or electrically isolated in the case of electric arc welding. To protect people working around you, the work area should be cordoned off, with welding screens which stop arc flash if necessary, and warning notices posted. Ventilation is important because breathing the fumes from some metals, especially if they contain zinc, can cause metal fume fever. Nausea, dizziness or aching limbs may be signs of insufficient ventilation, and you should stop work immediately and seek medical attention. The effects are normally short-term, but prolonged exposure can cause serious health problems. When working inside, just leaving a door open isn't enough. You should use a ventilator to extract the fumes. Make sure that it is in a position where it will draw the fumes away from your face as you work. In confined spaces, a portable ventilator is not always sufficient, and a respirator may be necessary. Any flammable material in the work area must be removed, and you should sweep away anything on the floor. Remember, sparks can travel up to 30 feet, so move things at least this distance away from your work. Sparks can also fly under doors, or drop through cracks in floors to start fires in other rooms, so make sure any gaps are blocked to prevent this. Anything at risk which cannot be removed from the work area must be protected. Wiring or piping should be covered with fire blankets to reduce the risk, and make sure the fire watch pays special attention to these areas. A fire watch must be appointed whenever hot work is being carried out. His main duty is to keep an eye out for and extinguish any small fires which the hot work may cause. The fire watch must be trained in the use of fire extinguishers and ensure that the correct type of extinguisher is available. Once the job is finished, and for around 30 minutes afterwards, he must make sure there is no smouldering material before leaving the area. Abby, above, below, behind, inside, is very important during hot work. For a start, it will guide the positioning of the fire watch by helping you determine where the heat and sparks from the job will go. Abby is also important in assessing whether the welding job could cause damage or an explosion hazard, which may not be immediately obvious. If you're going to be welding up against a bulkhead, for example, it's important to check what's on the other side. While we're talking about explosion hazards, you should never perform welding or cutting on any vessel or piping unless you are sure it has been rendered safe. If even a trace of a flammable substance remains, the chances are it will ignite or even explode. Oxyfuel welding uses an oxygen-enriched gas flame to heat metal to temperatures high enough to weld or cut. Both the fuel gas and the oxygen present hazards if improperly used, and it's important that you are aware of these. Another video in this series, Bottle Gas Safety, covers the correct procedures for handling and using these gases, so we won't cover them in detail in this video. But it is important to be aware of the characteristics of the gases you'll be using. Oxygen does not burn itself, but helps combustion. At high pressure, pure oxygen can cause oil and grease to combust spontaneously, that is, without a source of ignition such as a flame. So it's vital that all oxyfuel welding equipment, the surrounding areas, and your clothing are kept free of oil and grease to prevent them catching fire. Acetylene, the most common fuel gas, is a fairly unstable gas stored in special cylinders, requiring careful handling. Although acetylene dissipates readily outdoors, it can build up in areas without adequate ventilation, causing dizziness and even unconsciousness if breathed in. You can't see or smell either of these gases, but if they're handled incorrectly or allowed to build up, the consequences can be disastrous. Quite often, the welding kit will be fully assembled on the trolley and ready to use, but you shouldn't assume that it will be safe to use. There are a number of checks you should carry out on the equipment before any job. Begin by cleaning the cylinder valve of any oil or grease. Make sure there are no sources of ignition in the vicinity. Then stand to one side of the valve and crack the cylinder briefly to blow out any dirt. Inspect the regulator for signs of damage and make sure it is clear of oil and grease before fitting it to the cylinder. Before fitting the hoses, they should be checked for cuts or burns. Try to keep hoses clean, not only because of the fire hazard from oil and grease, but also because dirt can hide signs of damage. Hoses for oxygen and fuel gases have different fittings to prevent incorrect connections. It can be hazardous to mix the two in case traces of gas remain in the hoses. Periodically, the O-rings in the hose connections should be replaced to ensure a good seal. Company policy requires that flashback arresters and non-return valves be fitted to the hoses. Flashback occurs when the combustion rate is higher than the flow of gas to the torch, allowing the flame to travel back through the system. This can cause hoses and regulators to catch fire, and if the flashback reaches the cylinders, the results can be deadly. The arrestor prevents gas flow and extinguishes the flame. Non-return valves are simple spring-loaded devices which prevent gas flowing back and forming an explosive mixture in the hoses. They are not flame-proof and so must be used in addition to flashback arresters. Periodically, the non-return valves should be unscrewed and cleaned to make sure they are not blocked by dirt. Before fitting the torch, make sure that there are no signs of damage. Carefully attach the hoses and then close the torch handle valves. Now, open the regulator outlet valve to allow gas into the hoses. Once the system is pressurized, check for leaks at all joints with soapy water. If you see bubbles, you've got a leak. The final step before ignition is to purge the hoses and set the pressure by letting gas flow freely for a moment. Each hose should be checked individually. Remember, the acetylene pressure should never exceed 15 psi. 7 is adequate for most jobs. To light the flame, there's only one tool for the job, and that's a friction lighter or striker. Open the fuel valve a small amount to begin with, then adjust it until the flame is burning without smoking about 1/8 of an inch away from the torch head. Now open and adjust the oxygen valve until a neutral flame is achieved. A neutral flame is one in which approximately equal quantities of fuel and oxygen are burned. A flame burning with a whistling or hissing noise indicates a flashback, and the torch should be shut off immediately. The torch is shut down by closing first the oxygen handle valve, then the fuel valve. Reversing this procedure often results in a pop, which blows soot into the torch head and can eventually clog the gas tubes. If the system is to be unused for more than an hour or so, it should be shut down completely. Close both cylinder valves and then release the pressure in one hose at a time by opening the torch handle valve and regulator valve. Close the torch handle valve and check the torch head for damage or blockage. If you're taking a break while working in a confined space, remove the hoses from the area. Even a small leak can cause a dangerous build-up of gas in a confined area. When you've finished a job, make sure other people are aware of any hot items by marking them. Also, think about good housekeeping. Put the equipment back in the appropriate storage area and make sure gas cylinders are stored properly. Carefully coil and store the hoses to prevent damage and avoid trip hazards. This will help to make sure that next time you start a job, the equipment will be in good working order. Welding with an electric arc is potentially hazardous, so it's important to understand the basic principles. In electric arc welding, a spark between the positive and negative pole of an electric circuit becomes a sustained arc, generating temperatures of around 6,000 degrees Celsius. One pole of the circuit is the workpiece itself, and the other is the electrode in the arc torch. When the electrode touches the workpiece, the circuit is completed, and current flows back to the welding machine via the work or ground cable. This is connected either to the workbench or to the workpiece itself. The positioning of the ground clamp is extremely important for the safety and quality of the work. A loose connection can result in a weak arc and a poor weld. More importantly, a badly placed ground lead can cause the circuit to take an alternative route. An electric current always takes the path of least resistance back to earth, and it's important to be aware of this. A current passing through delicate equipment may damage it. More seriously, if it passes through flammable substances such as gas cylinders, it could ignite them. Remember Abby when setting up an arc welding job. Finally, make sure that you don't become part of this circuit. We've seen that proper welding gloves are important to avoid burns, but leather gloves also provide good electrical insulation. Water conducts electricity easily, and for this reason, you should make sure that all welding gear and protective equipment is dry, and that you are not working in a wet area. Electrodes consist of a current-carrying wire core, usually of an alloy similar to the workpiece, covered with a coating of flux. When the arc is formed, the wire core melts to form the filler material for the weld. The coating melts more slowly, forming a cup which helps to direct the weld. As it melts, it forms a gas shield around the weld to prevent contamination, and also provides a coating of slag to protect the cooling metal. Welding with this kind of electrode is called shielded metal arc welding. Because the coating is important to the quality of the weld, electrodes should be kept in good condition. They should be stored in a dry environment or dried before use, as moisture can interfere with the gas shield. For the same reason, cracked or damaged electrodes should not be used. One final thing to note about electrodes: they should only be used for welding. People often find other uses for a piece of wire, but electrodes are not strong enough to do other jobs safely. One of the main hazards when arc welding is the ultraviolet radiation from the arc. If you look at an electric arc without proper protection, the arc flash can do permanent damage to your eyes. Therefore, you must wear a welding visor with a darkened lens. The necessary lens tint will vary with the type and size of electrode, which should be displayed on the electrode itself or on the box. The UV radiation can also cause burns, similar to sunburn, on exposed skin, so ensure that all of your body is covered. The firewatch, who will also need adequate eye protection, should be positioned where he can easily cut off the supply in the event of an incident. Also, it should be ensured that only Class C extinguishers are used around electrical equipment. Inspect the welding leads and the cables on the welding machine for damage before connecting it to the supply. Cables should be protected from mechanical hazards, such as doors closing on them, to avoid cuts in the insulation. Someone could receive a shock from exposed wires, or the cable could weld itself to the deck. Try to find welding leads which are the right length for the job, as long leads can create a trip hazard. But cables shouldn't be coiled, as this causes induction and overheating. Inspect the electrode holder and check all connections on welding leads and clamps before use. Make sure there is no electrode in the holder before switching on the welding machine. As soon as an electrode is placed in the clamp, it becomes a current-carrying part and must be treated with care. Keep it away from your body, especially your face. When inspecting the weld without the visor, hold the electrode well away from any surface where it could accidentally arc. When the electrode is exhausted, discard it into a suitable container before putting the holder down. If the holder is put down on the bench with an electrode still in it, it is likely to arc. If you are stopping work for more than a few moments, switch off the welding machine. Once the job is finished, it should be disconnected from the supply, and welding leads should be carefully coiled and electrodes placed back into dry storage. Another operation which you may have to carry out is cutting or piercing metal. This is usually carried out using oxy-fuel equipment with a cutting torch in place of the welding one. In the oxy-fuel cutting process, the flame is used to heat mild steel to around 900 degrees Celsius. A jet of oxygen is then applied which doesn't melt, but actually burns and blows away the metal. Electric arc cutting and gouging works in a slightly different way. The metal is melted with the arc and then blown away with a jet of compressed air. This process requires a different electrode holder, but will cut some materials more readily than oxy-fuel equipment. You must be aware of where the large amount of sparks and molten metal produced by this operation will travel, and ensure that all the necessary precautions have been taken. Cutting is often much noisier than welding, so make sure you have suitable ear protection. If you are cutting large sections of metal or are dismantling equipment, it must be supported in some way so that it doesn't suddenly drop when the cut is complete. Structural members, which are under stress, should never be cut, because this could lead to sudden and catastrophic failure. An integral part of welding safety is the strength of the finished job. If the finished workpiece isn't strong enough to do its job, it's unsafe. So, using good technique to produce a high-quality weld is an important part of safety on the rig. We're not trying to teach you how to weld, but we will show you a few pointers to help improve your technique. The first step is the proper preparation of the joint. Thin pieces of metal can be welded with a simple butt joint, but mostly you will need to bevel the edges to allow good penetration. This will usually be a V-joint, or, for very thick metals, a double V, requiring welding on both sides. A common problem is an inclusion fault, where foreign material contaminates and weakens the weld. These are often impossible to see with the naked eye, so it is important to avoid them by cleaning the workpiece thoroughly. You should also keep an eye out for stray slag during welding. It's important to maintain the smallest arc gap possible, because a long arc causes spatter and may project slag into the weld puddle. Aim to keep the distance between the tip of the electrode and the workpiece about the same as the diameter of the wire core of the electrode. Often, the electrode will be exhausted before you finish the joint. When you break the arc, it leaves a crater at the end of the weld, which can create problems. Because the crater contains less filler than the rest of the weld, it cools more quickly and can cause cracks to appear. Before you strike the next arc, you should clean off the last inch or so of the weld to prevent inclusions, but you can leave the rest of the weld with its protective layer of slag. Then make sure the crater is filled to match the previous bead before continuing along the joint. We mentioned earlier the need during gas welding to achieve a neutral flame, in which equal quantities of oxygen and fuel gas are being burned. A surplus of either will affect the weld. A flame with a surplus of fuel is called a carburizing flame and can give off soot particles, while a surplus of oxygen will cause oxidization of the metal. There are several variables in the welding process, so before carrying out a critical welding job, you might make a practice weld using the same materials to check you have everything set up correctly. Looking at the surface of the weld will show you where you need to adjust your technique. The shape of the beads is a good indicator of travel speed. This is the rate at which the welding torch moves across the weld piece, preheating the base metal and melting the filler rod or electrode. A good weld will have evenly spaced beads of a regular, curved shape. It should be a consistent width with straight edges and a slightly convex profile. A narrow bead with a pointed shape indicates that either the travel speed or the electric current was too high. Moving the torch too quickly will not preheat the base metal enough for proper fusion with the filler material to occur. This means that the metals have not melted together and seriously affects the strength of the joint. Also, moving the filler rod or electrode too rapidly can result in incomplete penetration, where not enough material is deposited to reach the base of the joint. Undercutting, or valleys, where the center of the weld bead is lower than the sides, are another symptom of too high a travel speed. Either of these faults can cause cracks to appear in the weld. A wide and unevenly shaped bead indicates a slow travel rate. This can allow too much filler material to be deposited, resulting in overlap. A notch at the edge of a weld will become a focus point for stress and may eventually fail. At very low speeds, the torch will heat the base metal to the extent that it melts away, resulting in burn-through. A lopsided profile with overlapping on one side and undercutting on the other indicates an incorrect work angle. Aim to keep the work angle perpendicular to the joint to avoid pushing filler over to one side. Now that you have seen a few of the more common weld faults, you should be aware of what to look for in a finished weld. If you get into the habit of inspecting your work and recognizing problems, your skills will improve and you will help to maintain a high level of quality. Often, jobs will have to be completed quickly, but if you compromise quality, you're compromising safety as well. This video covered the main points to consider in job preparation and the use of oxy-fuel and shielded metal arc welding equipment. By completing the rest of the welder module, you will become a competent rig welder and a valuable part of the Sedco Forex team.